Hello, everyone. Welcome on in. It's a Saturday. We're having a nice, comfortable day today. We are going to be continuing our Attention's All You Need for Transformer. We're building it using the PyTorch embedded model. And you know what? We are almost there. We actually got it working. We just need to do a few things. We need to add some positional encoding. I need to finish the batching process. And then I need to test it to make sure it works. Token by token. And I think I have everything that I understand, all the details. I'm almost fully understanding of it. There's a few pieces I'm missing. The important one that I get a little bit better is this part right here. I get this a little bit better, this piece right here. I understand it now. Really, it would have been nice if they took the diagram and split it up a little bit. And it's interesting. Query key value. The value becomes this head right here, which is interesting. It's neat, right? Then there's also some extra bit here, right? You get a query and key from the initial input encoding, and then you get a query key, and then you get a value here. Also a value here, right? It's like a boop double. It doubles it up, which is so odd. It's very odd. And then it happens here again. All right. We're gonna learn through this. We're gonna walk through it. Okay. So, hey, Tech Maniac, good to see you. Yo, awesome work. Thank you. Appreciate it. Good to have you here. Happy Saturday. We're going to be doing some Python. So let me do a quick little link share. Let me go copy a link share here really quick. Over to our Discord. General. Oh, someone already. Wait. Oh, that happened yesterday. Yeah. All right. /everyone. Looks good. Nope, it always does that. Always does it. At everyone. There we go. All right, looking good. Okay. Hey, Jay Bro, good to see you. Welcome on in. Happy Saturday. Good to have you here. All right, let me get my windows all configured properly. All right, looking good. Okay, let's get back into it. So, where did we leave off? Do you guys remember? This was just yesterday. Okay, so we were batching. We were converting the batches. And I know this part doesn't work because it is a standard Python array. And this trick only works if it's a PyTorch array, which it can't do. You can't have a tensor, right? You can't have a tensor of strings, right? Can you have a tensor of strings in PyTorch? Do you guys know? Python. Let's find out. We're going to find out. Import torch. I'm pretty sure the answer is no. All right, torch.tensor, and then we can do a number, right? We'll get a number. Can it be a string though? String? Yeah, I didn't think so. I was pretty sure about it. That would have made it a lot nicer to deal with though. All right, we can't do that. So we're gonna have to do something different. We need to create a shuffle. We need a shuffle. So the plan is to shuffle here. All right, let's see how we're gonna do that. Okay, so if we've got our features and our labels here, and I want to create a shuffle from this, I need to get a list of indices. So what I could do is get these indices here and random permute our batch size. But the problem with that, no, I can't. I need to do it based on the total data set size. So I need to do it based on the length of the training data. All right, there we go. All right, so those will be the indexes. And then I will only grab the first 10. I will only grab the first 10. This is a wasteful though. I feel wasteful. All right. So, all right, to do works, but wasteful. What if we just did, instead, we just grab some random number? Although, is that also wasteful? Because aren't we calling out? Is it pseudo-random? Do you guys know what the performance is? So if we get this, oh, I suppose what we could do is do batch size and then grab the length here. Training data size. Training data len equals len of training data. So we'll keep this around. And then when we're permuting, we can just grab a random batch size. Then we can capture. Oh, what we really should do is make this a method here. Def, let's see, get batch. There we go. And then we're just gonna keep the data global. It's a machine learning. Hey, yes, you got it. Mather. Wait, hold on. Mathen Broad. Hey, Matherin Broadvex. I'm trying to. Hey, welcome on in. Good to see ya. Happy Saturday. Hope you're having a good weekend so far. It is machine learning. You got it. That's what we're doing right now. We're doing transformer. We're doing the attention's all you need. Mathen. Mathen. All right, I tried to say your name. Let me see if you got your name on your channel here. Go to channel real quick. Good to have you back, by the way. Thank you for stopping on back in. Let's see. Go to channel. There we go. All right. See, here we go. Mathene Broad Kvis. Mathene Bravagravus. All right. Good to have you here. Okay. So if we do this is going to get us a permute, our correct number. I do believe we need to throw this over here though. So we're going to get our indexes. And then I want to, so this will be batch data, or data batch, data underscore batch equals, or what we could even do would be even better. Nice try. I know, Dyer, thank you, appreciate it. I give it a shot. Mathen. Hold on, here, I want to see it, so translate. All right, how about this? All right, we'll try this. We'll say Mathene. Methene. Is it methene? Is that it? Methene? All right, methene. There we go. Hey, Torva, good to see you. Welcome on in. Happy Saturday. Let's code, guys. Hey, Steven, how are you? We're doing good, thank you. We're continuing on with our transformer here. And we're just doing a little batch. We're doing a little bit of a batch setup here. A quick little easy batch setup. So I'm going to return features and labels. So our features and our labels will equal the data that we're looking for. So we got our training data. We got the length of the training data. We're going to grab the indices. And then so now that I got the permute, we actually need to take this here. I think we need to take this whole thing here. All right, here we go. All right, so what is A for in training data? All right, so the part that won't work is this. We need to fix that. Hey, Kyle, whoa, Kyle, you're here on Saturday. How's it going? I wasn't expecting this stream. Nice. Good to have you here. Hope you're having a good weekend so far. I did some laundry so far today. I did some kitchen things and some food prep. And now I'm streaming here. Now we're streaming. I'm really excited. I think we're going to be able to get most of this completed today. If not today, then by Sunday as well. I think we'll be able to do it. Okay. So this part will fail. I know that. So then I want the features and labels to be a product of the result. So we say, what was this function called again? It's called get batch. Okay. There we go. Okay. So we'll just get a random batch there. This is what I do too. Really? You do too? Optimize the heck out of it, everything until it's perfect. Bug fixes also. Hey, let's code. Yes, that's the way to do it. Hey, Loons, good to see you. Happy Saturday. You made a blog today. No way, really? You, like a real human blog? Like a really you really typed it with your hands? Writing the first post. Nice. Original content, human created. There's going to be value in that. There's value. Okay, so we're going to shuffle. We fix the waste. Okay, so we got the featured labels. Now all we have to do, let's see, return features and labels. All right. Next, I need to fix this. So this part right here is going to fail. This section right here will not work because training data is a normal Python array. It is not a tensor, and tensors can have strings in them, so it cannot address these indices like this. Have a great replenishing rest, Kyle. Yes. Have a great stream. All right, thank you, Kyle. Good to see you. Let's see if we can make our way here. Let's go. Oh yeah, Kyle, that's right. You had some health considerations. Hope you're doing better. They're transferring me to Sunnyvale. Wait, Sunnyvale? Wait, California? No way. Never been there. Hope I adjust quickly. Sunnyvale. Wait, hold on. Wait. You have to move? Or do you have to just go to a nearby place that just happens to be a different office? Or a different building? Let's code, guys. I'm curious about that. Because it's unusual to say, okay, you're moving now. You have to move your entire life and go to a completely new city, move, leave your place, and then go to a new place. By the way, my blog is just a pure HTML, like no CSS. Oh, what? No way! Only HTML? No? Whoa. Yeah, now you're on performance land, right? No CSS, no JavaScript, just HTML. You know how fast that web page is going to be? It's going to be so fast. HTML only? That's amazing. Not just for Office? Okay. That's good to hear. All right, so I need to do a All right, so I need to grab an element from this. So this needs to be a range in the index length. It's actually going to be a batch range, right? So what I can do is random the batch size, and then I also need to adjust. Really what I want is a random number between 0 and the length of the training data. And then I can create a range of that and then do a list comp. Hey, Mark Lemon, good to see you. Happy Saturday, brother. Good to have you here. Yep, we're going to continue on with our transformer. How old are you? Let's see. I am in my 40s. So I am in my 40s, you guys. I'm old. I've been around for a while. We've been doing this technology thing for quite a few years now. Good to have you here. So let's do a quick little introduction here. Quick little intro. All right. My name's Stephen Blum, CTO at PubNub. We raised 134 million Series E, 1 billion devices connected to my network. I always show my phone when I say that. Here you go. Here's my phone. 68 patent claims granted. You can see them on my LinkedIn if you visit my LinkedIn. They are listed there. Our tire in Washington. Oh, whoa. Nice. Near my fiance's house or my home in North Carolina. That sounds like a good... Well, wait. So Washington State, right? That's where I am. I'm in Seattle, Washington. You guys. It would be neat. But North Carolina and Seattle, Washington are pretty far apart. Which one you want to do? Hey, how's it going there, Nichwa? Good to see you. Happy Saturday. Hello. Loons is writing a post right now, so there is nothing right now, but here's a link. Oh, a link. All right. It's hosted on Cloudflare. Very nice. Let's take a look. Workers, so unlimited bandwidth. Okay. Here we go. Hi, I'm Loons. My website, loons404.com. With your portfolio. Articles, the reason you're here. Not much else to see right now. All right. Getting away. Is inside job real? Hold on. What do you mean? Retro. Hey, Retro. Hi. Good to have you here. All right. Let's see. Welcome on in. Happy Saturday. Retro. Let's see. I think after my retirement. Okay. Sounds good. Retirement coming up. It'll be here pretty soon. Happens faster than you think. Okay. We got training data length. I'm going to get a random... Here's what I need. Google, I want PyTorch, random int between 0 and x. Random int for 10 elements. I would suppose. I think that's good. I think we'll try that. Let's see if I can get that. All right. Let's see if PyTorch has this. Oh, I've got randint. Of course. Randint. Why didn't I just think of that? Randint right there. Okay. I should have just used that from the get-go. Okay. Index is going to be randint. Torch.randint 0, comma. Then we have batch size. Oh, not, batch size will be here. Batch size as a tuple. And this element, the second argument is going to be the training data length. Training data length. We're right here. Okay, perfect. Okay. That's much better. There we go. I was going to do all sorts of fun, random things. I was going to import another library. How is the transformer progress? I missed a few live streams. Nitwa, hey, we're good. We actually succeeded. We got it working. It learned how to say words. It worked. We got it working. Now we're going to train it on a couple of things. So we got a couple of things to train it on. One is we've got some math data. I'm going to teach you how to do math. So first, that's the first thing we're going to do. The second thing we're going to do is teach it on some actual data, like, some real text. So that way it might even become a chatbot. We might turn it into a chatbot. You come from your Insta. Oh, all right. That's great to have you here. That's right. And absolutely love your videos and your energy. Keep it up. The world needs people like you. Thank you so much. That's nice of you to say. Oh, that's great. Do you know the show? Inside Job. Oh, yes. Okay. I thought that's what you were talking about, but it didn't. I wasn't sure. Yes, there's a movie. There's a movie. Here. So watch this. Google Inside Job movie. Here we go. Oh, yeah. Check that out. It's got Matt Damon in it. Comprehensive analysis of the global financial crisis of 2008. Oh, what? No way. 20 trillion cost, but millions of people lose. That was about the 2008 financial crisis. I've not seen it. I've heard about it, though. I wonder if Torch has Rand range, too. It does. It has an A range. It has a Torch A range. Python import torch.a range. It has this method. I know it does. It has this method. So, can we dir this? We can dir that, but it's not going to do anything here. Is there a way to inspect in Python? Do you guys know this? Congratulations. So what is the task for today? We've got some tasks for today. So, all right, let's do this. So let's do some to-dos. All right. So we're going to write some to-dos. To-do. Let's write a few to-dos here. Okay. We need to train on math. We need to finish batching and shuffling. Right? Batch and shuffle. And how's it going there? Hi, bro. How are you doing? Great job. Thank you. Appreciate it. Good to have you here. You were devastated by... They canceled it. Oh, wait. They canceled it? Wait. It's not a real movie anymore? Nice. Let's go, guys. Hi, bro. Really doing a great job. Appreciate it. Thank you so much. My blog post will be on my agent for blocks. Oh, Loon, that's great. Very nice. All right, Loon, that's exciting. That's very exciting. Okay. So training on math data. So we're going to just teach it basic math. Teach basic math. We also want to add positional coding, which I keep pushing off because I know we don't need it for a small amount of data. And it gets more necessary if we get larger amount of data. Yeah, they canceled Inside Job so they could go with Big Mouth instead. Oh, what? No way! So Big Mouth, the animated series on Netflix, that seems like a big shift. That seems like a big shift from like, what seems like a AAA movie with an A-list like Hollywood player, Matt Damon, to go with an animated series. Although I have seen Big Mouth and I did like it. All right, you guys. So, we've got some good plans here. We got some good plans. Do you know 42 Coding School? If you do, what's your thoughts on it? I have heard of boot.dev, of course. I've heard of Khan Academy, Code Academy. I have not heard of 42 Coding Schools. Let's take a look at it, though, real quick, shall we? Wait, before I do that, I want to see. Google, all right. Python, how do we do this? Python inspect function args like dir. Oh, wait. There we go. All right. Let's see. There's a dir. Yep, there's a dir. Inspect.signature. Oh, I need to import inspect. Okay. Yeah, I don't really care. But it answered my question. I tried MLflow. It was amazing and efficient. Let's code, guys. That's on the list. MLflow. Thank you for the recommendation. We got to do that. J-Bro, what's the name of the agent? The agent? Which one? Are you talking about... Actually, I actually don't know. There's a lot of agents out there. Hey, Dar, good to see you. Welcome on in. Happy Saturday. Kaga, how's it going there, Kaga? What are we doing today? We're going to be training a transformer on math, and we're going to be batching and shuffling, and then we also need to do positional encoding. You know, that sort of thing. Encoding. There we go. Yeah. Till how much live? Oh, for a while. At least a couple hours. So we got plenty of time. We're going to be here for a while, you guys. Strap on in. You've got a question. What do you think about universities make students write code without internet completely? Oh, yeah. Well, you need to, it's the struggle. So here, check this out. This is very common. This is also how I learn, and I assume how other people learn as well. The biggest part of the learning process is your difficulty in struggle. It's the struggle. It's the part that's hard because it invokes these emotional responses that create the strongest connections in your synapse, right? So when your brain is creating knowledge, the struggle is what makes you learn. If you get an easy option, you might have an okay time kind of somewhat learning something. You mostly will forget it. It'll mostly be forgotten. So the important part is to making it difficult. That's what we're doing here for this most part. I'm trying to make myself struggle in building this transformer. I'm happy getting help from chat because I feel like that part is fine because then I get to talk to you about it. And then otherwise, I'm not going to try to refer to anything that's going to really give me the answer straight up. So I'm going to try things and then I'm going to fail. Failure is critical. That failure is what creates the knowledge foundation that you need to remember things forever. Forever. On exams. Oh, wait. On exams? Well, I didn't read that part of your message just now. Yeah, if they're teaching you, they want to make sure you're not cheating. I think that part's obvious, right? Weights and bias also good, like MLflow. Oh yeah, I've heard of weights and biases, yeah. Weights and biases. I heard about this. I have not used it directly, but I want to try MLflow first. So MLflow is on the list. Please call you Vishal. All right, Vishal. Okay, Vishal. Got it. Do you use Swigglue activation? We do have Swigglue activation right here. Right there. You remember? It's right there. Okay, it's actually a very good point. Nice. Vishal, nice to meet you. All right. Name of the agent you are making, like Gemini or DeepSeek, etc. Oh, J-Bro, got it. In this case, I'm just making a transformer. Well, I mean, but I'm pretty sure you already know that because you've been here for a while. We're just building this. We're building this right here. This part, the famous thing that makes ChatGPT. This is what we're working on right now. Oh wait, you don't have positional encoding yet. No, I didn't. I haven't added it. It's empty. It's empty. I know. Like, come on, Steven, I haven't done this yet. Other things came up, you guys. So that's why. Simple and easy. Okay. Getting the songs going up there. There we go. Ooh, this is a good one. All right, let's get going. Transformer Decoder Framework. Yeah. Jeremy, you got it. You got it, Jeremy. Exactly. Jeremy Evan. All right. Okay. So let me see here. Where do we leave off? I want indexes. Here we go. All right. We've got a random int here. And then I need to do a loop over my training data. And then Before I do that though, I want to print indexes. I want to make sure this is exactly what I want. And then we're just going to return 1, comma 1. And then I'm going to pass here. Break is what I'm going to do. I'm going to break. Okay. Python transformer. I should see. Yeah, there we go. That's what I'm looking for. All right. Did we get anything that's like close to the 90s? I did. Okay, perfect. All right. That's the line I'm looking for right there. You have example code for sinusoidal? Do you? Nitsa? Okay. Let's do it together. That's why we're here. That's why we're on the internet. If you want, I'll share the link in Discord, and then we'll go take a look, and then you will inspire me to write. I will write it out. I won't do a direct copy paste. I want to see what you wrote or what you're referring to, and then I will sort of make it my own. That's how I help myself memorize things. Failing makes me sad though. I know, right? I know failing makes me sad too. You know what though? Derek, you know what? It's okay, because you get to try again, and you get to keep trying over and over and over. If you fail and learn, move on. Eventually, everything works out. Exactly, Jeremy. Sure thing, I'll share in Discord. Nice. All right. Let me know when you got that, and then we will do our positional encodings today. I'm so excited. Okay. Hey, Kurt, how's it going there? Hey, Steven, do you go to hackathons from time to time? I used to go to them very frequently. I used to. And then I got old, and I'm like, I want to stay inside now. I want to stay inside now. It's on Discord? All right, thank you. All right, under link share, maybe? Here we go. Sinusoidal encoding can be seen here. Perfect. Perfect. All right. Let's see. Oh, positional encoding. Here we go. Looks good to me. And it looks like it's PyTorchy. Oh, wait, you have dropout? Wait. All right, my question to you, real quick. Is there any learned parameters in positional encoding? No, there's not, because it's register buffer. Okay. Whoa, look at some magic sauce here. What is that? All right, I'm going to copy and paste this, and then I'm going to implement it in myself. So this looks like it is a feed. No, here's the forward. Okay, here's the forward. You even have dropout. You have dropout in your positional encoding? I didn't know you could do that. All right, I'm going to copy and paste this and put this into a separate file. All right, pb paste into pe.py, and then we'll refer to it in a moment. Because here's the deal. I'm doing your own AI assistant as well, but the program is with the exam part. The problem, oh, got it. Oh, the problem is with the exam part. Python is based for using libraries. If you haven't used a single one, the code be angry. All right, and the thing, without internet, you're unable to see exactly how to use a specific library. Okay, yeah. So here, we just Googled that, right? So here's a Google. Check this out. There's a way to do it. It's called inspect. Let's do this right now. Let's do this together, you guys. So we're gonna import inspect, right? So Python import inspect, and then import torch. Torch.arange is a function. What's inside the function? I don't know. Let's find out. Inspect dot, what do we do? How do we use it? How do we use inspect? Signature. All right. Signature in torch.arange. So we got there. I spelled it wrong. Inspect. No signature found for, oh wait, okay, never mind, that didn't work. I was like, check this amazing thing out that we could use while we're not on the internet. Nope, just kidding. All right, 1 second. Is it here? Okay. Yeah, that didn't work at all. Like, not even a little bit. Here, let's see if we can go. Let's see where I failed. Yeah, there's dropout. Okay, got it. I'm so curious about that. I'm very curious. I'm very excited to read it because I didn't know. I thought positional encoding would just be independent on its own, and you added dropout to it. What? That's crazy. Steven got to say this. Coding is a GPT on your own. You're inspiration for every programmer. I know we're doing, thank you. Jeremy, thank you. Yeah, we're doing hard mode stuff, right? I think that's really good because I'm at that point now in my life where I feel like I've known enough coding, right? Why don't we go on the most difficult challenges? Let's do the most challenging things. With longer. Longer. Got it. Thank you, Retro, thank you. I had to shorten because YouTube limits the input. Typing text, yes. All right. Oh, there's a help. Use the built-in help. That's what I wanted the whole time. I've never known about this. All right, you guys, watch this. Help torch.arange. There we go. Look at that right there. There's a built-in help method right there. Hey, Retro, look at that. We learned something new just now. Look, you get all of the methods right here. The full function definition. Start, end, and step. Isn't that great? Output, D-type, layer, device, and requires grad. Right there. It's called help. Have you ever? I've never used that before. I'm going to be using that going forward now. Commercial name of the agent when you release it. Oh, J-Bro, got it. Yeah, this is going to be a toy. It's a toy agent, so I wouldn't release it. It's already on a GitHub repo. If you want to go, it's yours for free if you want it. It won't be useful. It's just a training. It's just for learning. Without dropout, it also works. It acts as a regularization for the positions. Niswa, thank you. In Visual Studio Code, we just hover over a function and it tells us everything. But VS Code is a bit slow. Yeah, that is true. Yeah, that is true. The automatic in VS Code. Yeah, so type hints. And look, it gives you all the docs right here. So look, we learned together, you guys. And it tells you everything you need. Oh, this is great. Right there. It gives you an example even. Whoa, all right. This is great. Hold on, wait. Help print. Can we do that as well? Hey, look at that. It's got some help on the print right there. Did you know there's a wait, look at all these arguments in print. I didn't even know that you could do these things. Huh. You love Vim, so no functions readily accessible. I love Vim too, isn't it? Isn't it great? It's wonderful. All right. So let's keep going. Let's make our way. You guys. All right, now we've got our batches. I think I got everything I need here. And Neatswat, thank you. We'll get to positional encodings here, PE, in a little bit. And we'll look through what you did, and then I'm going to build something similar. I see this part here. This will stretch it out. I'm trying to see what that does. Best text editor ever made, isn't it? It's so good. I love me some Vim too. It's my #1 favorite text editor. Neatswath, yes, thank you. I appreciate it. Okay. All right, let's go into Python transformer. Okay. Yep, looking good there. All right, that's exactly what I want. It's got the batch size and everything. So we're going to create a range, and then we'll get our training data. All right, perfect. All right, so for range in, could we enumerate? I suppose we could. Enumerate it. Although we have to loop through it twice. What's better? What's faster? Is it faster to loop? It's faster to loop through things once, right? So for range, for index in range of indices. I guess, well, no, we do batch size, right? Batch size. There we go. We're going to say features, comma, labels equals empty array. Okay. BERT does not use sinusoidal. Oh, they don't. They use another embedding block and let the model learn positions by itself. Really? I was wondering about that. You know why? Because I was like, I was able to get this work without any positional encodings, and it learned quite well on its own. And I was so curious about that. Hey, how's it going there, top 1% engineer? Good to see you. Happy Saturday. What's that PDF with the flow chart? This is the attention's all you need. I'll throw this on our Discord under link share real quick. Link share. There we go. What? Okay. To this day, I'm still learning more and more stuff about Vim. It's so great, isn't it? Oh, I got a good one for you. Here, check this out. I don't know if you've done this before. You can go into visual mode, and then you can press Shift, double quote, plus Y, and that will copy it into your system buffer. So you can paste it directly like that. Isn't that? I like that one. That was my favorite. For over a decade, I used a different shortcut that involved the function keystrokes to do invoking of a special command that I didn't need. I didn't need it. It was already built into Vim this whole time. Finally, finish your blog post. Hey, all right. That's great to hear. Let's see if I've got it up here. Did I keep it open or did it? No, I got it right here. Loons. Where was it? Did I close it? I must have closed it. All right, let me scroll back up. Oh, you've got it right there. Okay, perfect. Hey, here we go. You can look at them, one small, one bigger. Okay. Nice. Docker Python open code server blocks it. Hey, look at that. This is great. Devlog, one of the Blocks API agents maker, participating in the hackathon. This means I need to make an agent on Blocks AI network. I already started an agent. And this agent, an agent maker, an agent that makes makers. It's an agent maker, you guys. This agent should be ready in about 1 week. All right, sounds good. The tech stack I'm using is Docker, Python, OpenCode, and Blocks AI. Pretty good to me. Looking good, looking good. I'll never compete with you in any coding competition. You code while I sleep and eat. I'm unaware. Hey, Lions for Lambs, good to see ya. You know what? You can compete. You can. Don't let anyone ever tell you or dissuade you otherwise. You can do it. You can do it. Great, great. I'm great. Are amazing. Happy Saturday. Nice. Top one. But why Vim and not IDE? You gotta use the IDE that makes you happy. That's an easy answer, right? Which text editor do you use? Well, which one do I use? I know. I'll use the one that makes me smile. Right? The one makes me happy. And that for me is Vim. Right there. Can I also ask who are the sponsors of PubNub if it's okay? Absolutely. Wait, sponsors? Are you talking about our investors? Right? So we've got 134 million venture capital raised, right? So you can go to Crunchbase and you can see, let me log in really quick. And then I will go to, search in PubNub, right? Pull up PubNub. And you see, let's see, funding. Here we go. There you go. Here's all the answers, you guys. You want to see who our investors are? It's public. All right, here we go. So we've got the Rain Group. We've got Cisco. You've heard of Cisco. We've got Ericsson. You've heard of them. You might have heard of Sapphire Ventures, Scale Venture Partners, Relay Venture Partners. And there you go. That's an easy, quick one. It seems to be missing. It's definitely missing some because I noticed that there's extra. Oh, no, here's other ones. Here. Bosch, Hewlett Packard, and Clear Vision. You've probably heard of HP. You heard of the HP company? Yeah, they invest in my business, you guys. Ericsson still exists. I know, right? Sublime, there you go. Sublime, nice. Have you heard of CTFs? Wait, have I? I don't know, Retro. Like Sony Ericsson, yes. Yeah, you got it. That's it right there. Cisco and Ericsson right here. You got it. No, they broke like a while ago. They are still a thing. I know they're around. Capture the flag, of course. Of course. I used to play a lot. I played Soldier of Fortune and what is that? Counter-Strike. CTF. Thank you, Retro. I forgot about that. It's just been a while since I played FPSs. All right, Loons, let's see what else you got over here. Loons. Where'd you go? Are you around here somewhere? I didn't close you, did I? I didn't close you again. There we go. There we go. Okay. Have you coded a GAN from scratch on stream? Hey, Henry! That sounds like a good idea. I would like to do that. Let's do it. Let's create a network. See, GAN AI. What is this? This is a... No, that's not correct. It's GAN model. There we go. Generative adversarial network for images, right? That would be also fun. Let's add that to our to-dos, you guys. Let's do stream ideas. And we will create a new stream idea. We'll call this a GAN for image generation. We've made an image generator before on Stream Live. We have. We've made one. You can check. It's there. Make pretty images from AI. All right. And this is Python and AI. Post. There we go. Idea registered. Nokia is working on their 6G. Is that real? Probably. Probably real. I mean, why would they just stop at 5G? If they've gotten up to 5, they're like, oh, wait, no, it's good enough. 5 is fine. We don't want to go to 6. There's no need for 6. 5 is good enough. They're probably working on 6. Henry, yep, that it. Nice. Good to hear it. You were number 4 talent on board in Capture the Flag from HackerOne. Whoa, no way! Retro, are you serious? Yeah, I know HackerOne. I've met them. I've met the people. I met some of the people who started it many years ago in San Francisco. Many years. I mean, even General Electric exists. Yeah, GE. Yeah. This GE Finance and Verona GE Healthcare. Oh wait, really? They split up. Interesting. I forgot about that. All right, we got to finish Loon's blog post really quick. I receive a request in Blocks AI. I spin up a new Docker container. In this Docker container, I install Python logic, Node.js for OpenCode, and the Blocks AI CLI to publish the finished agent to Blocks. I send the request to OpenCode for detailed prompt explaining everything so it can build the agent. When OpenCode finishes, you start a new session of OpenCode and tell him to check everything. Gotta double check, make sure it works. Step 5, most people forget. That's a good one. Hey, this is brilliant. Number 5 is my favorite. When the second session of OpenCode corrects any bugs, I install my Python dependencies using OpenCode. I call the handler.py to make a last test to make sure that it works. When every test passes, I finally blocks publish, listing public, billing mode free to make the agent public. That's amazing. That's amazing, Loons. Then I return generated URL because the block CLI give an URL because the agent URL are just, yes, exactly. There you go. That's it right there. You can guess the URL based on the agent name. The generated agent will run for 30 minutes in the Docker container. Very nice. If any of those steps errors out, I tell OpenCode to fix them. So this is the whole workflow. I don't think it's hard. And if you were wondering, so why there are so many tests, it's mostly because the free model I use OpenCode, it's a big pickle. It's dumb. Yeah. So you just have it run and you have it recheck and check again and make sure it tests and and then you make it work. That's great. Loons, that's beautiful. Good job. Good job, Loons. Oh, retro. Yeah, okay, so back in 2017 or 2018. Almost 10 years ago. That's almost 10 years ago. Jeremy, still code in Code Forces. Wait, at Coder and LeetCode. Oh, yeah, LeetCode. Just for fun. Yeah, they're for fun. Those sites are games. They're for fun. It counts for games, you guys. Retro, thank you for subscribing. Yeah, that's amazing. Thank you. Appreciate it. You joined the right channel for software engineering. That's what we do here. We do some software engineering, you guys. 1 second. Let me adjust something on my side. 1 moment here. There we go. Okay, perfect. All right. Let me get back to the chat here. Let's see. Just wanted to let you know, I started up my company. Oh, you did? Hey, congratulations. Name the first principles where we make a t-shirt and hoodie for nerdy community. All right, for the nerd community. We put the quotes, STEM, right? Science, technology, E, and math. What's E? E is education. I forget what STEM stands for. Science, technology, education, math, maybe? Hold on. STEM acronym. Science, technology, engineering, and mathematics. Okay. I got 75% right. Very nice. The quote, the motto of life is to become a vector from scalar. Become a vector from scalar. Yeah, I like that. A scalar, single value. A vector, multiple values. Very nice. I like it. How's it going there, Monomoke? Good to see you. Have you played 007 GoldenEye? Yes, I have on the Nintendo 64. I played that game so much. It was one of the best games. It was so impressive with what they did. First-person shooter on the Nintendo 64. I sure did. Monomo. Yep, I did. I sure did. Engineering. Haramana. Hey, Haramana. Thanks for saying hi. Appreciate it. Thanks for the floaty hearts, you guys. All right, let's get back to our code. Let's get back into our code. I want to do some more Python. Do some more Python here. All right. Some more AI. You should play 007 First Light. I saw it came out. Yeah, I should probably play it because it kind of brought back some nostalgia from the GoldenEye days. Now we all know the games. What about Half-Life or Portal? Yes, I played those too. Those are great. I loved Half-Life. I loved Portal. First-person shooters. The retro. Yeah, I have a lot of consoles. My dad works at Sony. No way. He was your inspiration behind engineering. That's awesome. That's amazing. Nice guess, but my thought was that a scalar has a magnitude and a vector has both magnitude and direction. Oh, yeah. Okay, I'm thinking computer engineering, right? So for example, a scalar is a single value, right? So let's try this. So let's see, Google, in PyTorch, a vector is 1D array and scalar is 0D array / single value. Okay. Correct. In PyTorch, a scalar is a zero-dimensional tensor. Rank 0, containing a single numerical value, while a vector is a one-dimensional tensor, rank 1, containing a sequence of list of values. I told you. In life, everyone has a magnitude, but only the successful people have a direction. I see what you did there. Yes, okay. So that is more physics oriented. That's more on the science side. Technology has different meanings. No way. I know, right? The workflow to make a big blog for me is you use GitLab, Web IDE, connect to a repo, and write your HTML. No AI, and commit. Cloudflare detects it and sends it out to the internet for deployment. What's your favorite Android app? What app do I use the most? Well, I mean, I guess... What do I even do on my phone? Let's find out, you guys. Well, I mean, it's just social media. That's it. I just scroll. So like Instagram, TikTok, and YouTube. That's it. That's all I do on this thing. That's it. I don't have a favorite app. I just use the social media and I doom scroll. Hey, how's it going there? Xiao Yu Yen. Good to see ya. Welcome on in. Happy Saturday. Okay. Now we can get into coding, you guys. Let's get into some coding here. Python transformer. All right, where was our issue at here? Let's close these out. Okay, let's try this. Pass, break. That's what we're gonna do, break. There we go. See, we're good? We're good? Okay, no errors, good. You're very interested in Jeppa stream? Yeah, I was looking at that. Are you going to finish Transformer today? We might finish Transformer today or tomorrow. the pending, right? So you gave us the positional encodings, which is a big chunk that we want to do. I need to finish up the shuffling and batching here really quick. And then if we finish with it, we can start on the JEPA. The thing is, I was looking over it. We will start with the paper. We'll start with the paper and we'll see where we get. Maybe we can make it a mini VJEPA, right? Something like a mini. Or we can do some fine tuning, right? That might be good. Or we might build one from scratch. We'll see how far we get. Sounds great? Nice. Good to hear it. All right, so we're going to do features dot append. Same with labels. Okay, we're going to append something here. We're going to append something inside of our training data. Training data. Oh, wait. Okay. Sample equals training data index. And then we're going to get sample. And then I believe it's question answer. So features will be 0 and labels will be 1. That's it. We did it. I think that's it right there. Here we go, you guys. All right. Get batch. And let's print these guys out. Print features and labels. And then we'll break. All right. How many epochs do we have? Okay. Looks good. Looks good. Okay. Looks good. Yeah, that looks about right to me. Okay, I think so. Is it shuffled enough, though? I should see bigger numbers. How big is our number? It should be a range between 100. All right. So, hold on. Oh, wait. Hold the phone. Hold on. Yeah. Array. Append another array. Yeah. Okay. Return data. All right. Your PyTorch playlist is good. You can do some Udemy or Udacity. Oh yeah, courses. It's a good way to make some extra money. Oh yeah, I didn't even think about that. We could be a teacher. We could be a teacher and actually put out some legitimate courses. Some things that make it easy. So easier to learn. Money is much needed in an organization. Those cloud bills get, oh yeah, they do. It get expensive. You're absolutely right. All right, let's update our playlist here, you guys. Let's go to the next page and start the next. Here we go. Excellent. All right. I like that idea. This is a really good idea. Jeremy, I should do that. All right. Here we go. So my output looks accurate. It's just too small. Oh, actually, you know what? It should be random. So if I just keep running it. So I see 14. That's good. I see... the numbers are not being large enough. Although it only goes up to 9 plus 9. Is that correct? Is that how we do that? No, it should be up to 100. It should be up to 100. So why am I only seeing small numbers? This is weird. All right, we got something weird here, you guys. Some weird things happening right now. This is odd. All right, why is it doing that? Because if we look at our training data, it's going to be quite extensive. So let's print all of our training data here real quick. Features get batch. Yes, batch here. Training data. You grab the end. Oh, yeah. Okay, I see what I did wrong there. All right. We need to not just the index. We need the indices. So indexes. There we go. I forgot a little bit right there. I was like, why does it look broken? Oh, that's why. Let's give the stream some cool song in the background. Propose dual core superpowers. Oh yeah. Hey Retro, I would love to do that. The thing is, we're on YouTube and they like their copyright considerations. It's all automatic. Even a couple of seconds of a song that is copyright, it will take over. It'll take over immediately. It will consume the entire stream. Not just for like that one portion, which I think would be fair, only for what that portion of the stream was played, right? So if I play it for 2 minutes out of like a 3-hour stream, it should only count for 2 minutes. No. It counts for all 3 hours. Really? Yeah, it does. It's kind of unfortunate. All right, so that should have fixed that problem. All right, there we go. That's what I'm looking for. Now we've got the correct data. Yes, that's exactly what I wanted. Excellent. All right. Listen to that song for yourself, maybe. Oh, it's a good one. I do like that. Dual core superpower. What's the brain power? How are they different? Here. Let me look it up real quick. I'll search for it. It's called, you said, dual core superpowers. Couldn't find? It says it couldn't find it. Dual core superpowers. Here. Or maybe Spotify is having an issue right now. Yeah, their search isn't working. Okay. Oh, no, it came up. It finally worked. It just took a while. I don't know if you could see it, but it is showing up right here. I'll try to listen to it just in the corner. Hey, Peace Lord. Hello. Good to see you. Welcome on in. Happy Saturday. I'm trying to see if I recognize the sound. I recognize this. A good one. Yeah, I haven't heard that for a while. Oops, it's still going. Hold on a second. Yeah, good song recommendation. All right. What are we doing? Peace Lord. All right, so we just finished batching. I'm pretty sure. Now we got to make sure that it works. So we did batch shuffling. So we did, where is he? Finish batch shuffling. So we're going to do this real quick. Then we're going to do positional encoding. And we're going to train our model because we've succeeded at building a transformer. That's what we're going to do. We're going to train it. We're going to train it on math data. We're going to get it to going on the math. And then we'll try to train it on some more data. We'll do another to-do, train on like big data. Batch train? Yes, batch train. This is where we take our, we've got our data, right? So you see all of our data here. This is all of our data. All the letter P's that you see on the screen are padding. So they're just empty, they're blank tokens. You can think of them as blank tokens. And we're going to ignore those. They're just there for padding. And then we train on batches, which allow you to submit the full batch to the GPU, right? Pop a whole batch over to the GPU. The GPU can turn on it. It gets warm. It catches electricity, and then it gives us the result all in a batch. That's why we do batching. I also do batching for a regularization perspective, because when you do loss calculation, it's kind of more of a batch cost because you average it out across the entire set when you calculate the loss. So there's a couple reasons why you do batch. Additionally, you want to do shuffling, so you randomize it, right? The stochastic part. Batching improves accuracy. Yeah, it does. The final output, yes, it improves generalization. You got it, Peace Lord. Makes our generalization better. So we basically did this. I just need to confirm that it works. All right. So we've got our data that's getting our features labels. We're looking good. All right, let's see if it worked now. Let's see if it works. Did we do it? Did we make it work? This is where it has to labels and then target labels. We're gonna have to do a couple of things. There's one other step we got to do with the labels here, but this will work fine for now. It's fine. Okay, looks good. Looks good. All right, let's find out if it worked. Please. Hey, look at that. All right. That's what you want to see right there. That's it. We did it. You did batch for multi-class classification. Batching, it's worth it. It's worth it. I think batching is necessary for basically everything, unless it's like a very small data set and you don't necessarily need batching in that case. However, it could be still beneficial. I say always do batches. Thank you for clicking the hi button, Loons. Great blogs, by the way. That was actually a lot of fun to read. And it was properly architected too. Like, I don't have any change recommendations. You did everything. You figured it all out. Very good job. Okay, so now, is this transparent beer? Beer. Hey, I was going there. T. Brimard. Hey, T. Brimard, good to see you. Happy Saturday. What is transparent beer? Wait, what do you mean? The song. Maybe? The song is Apollo Patrikos. Okay. What you drink? Oh, of course. Yes, technically, it's the primary substance in all beverages. The water. It's the number one ingredient. Hey, Sergio, good to see you. Happy Saturday. Hope everyone's a wonderful weekend so far. So far, so good. We're so excited. I was like, I wanted to stream, and I wanted to talk to you guys, and I wanted to build, and I was just thinking about it, and I woke up at 3, and then I went back to sleep a little bit, but I was thinking about it. Calling it water transparent beer. Yeah, I figured. I should have said, yes, it is technically transparent beer. Because even though, thank you though, I do appreciate it. Sarcasm is welcome. Okay, so now that we've succeeded there, and our loss is looking really good, we should do one other thing here. We should do label teacher leading. There's some sort of lead or teacher thing here. Lead? Is there a lead? Lead. Teach. Shifting. Shift. Here we go. There's something with shifting. What? Shift. I know there is because I saw it. It was in the diagram. Why can't I search for it? In the paper. Was no search. Shifted right. Okay. Here we go. We need to do this right here. The shifted right part. Vodka is transparent, J bro, right? It could have been vodka. It could have been. And it might be. It's water. Don't worry. It's water. Where are we at here? So, do we need to do this? I need to do some shifting, and I forgot how to do that. We need to... The input target needs to exclude the last token, and the final token output needs to include the token. And then we calculate the loss on how wrong it was on its predicted out token. SHL? Wait, what is SHL? What is SHL? Wait, I'm very new at this. Hey, all good? Good to have you here. Wait, what is HSL? I'm an HSL acronym. Is that a thing? Hue saturated? No, it's not. I'm pretty sure that's not what you meant. I'm almost certain that's not what you meant. Assembly for shift. Oh! Yeah, what do you know? That is impressive that you memorized that. Very nice. Shift the right label so token X at position I predicts token position I. Yes, exactly. Exactly. That's what I need to do. I need to do that part right here. Right now I'm having the model just predict it, so it sees everything. It sees it all. So it's like, oh yeah, I'm gonna learn that, no problem. We need to give it some work. Steven is a fitness conscious person. He will not be drinking vodka on the stream. That's right. You know it. Just water and broccoli, you guys. Water and broccoli. Let's see. Where are we? Okay. I might stream for a little bit longer today. I will have to eat, though. Eat while on stream. We might stream a little bit longer, but I will have to grab some food. Broccoli is your favorite food? I would say I would say broccoli is, if I had to pick one vegetable from a health and from a taste perspective, broccoli would be probably the best. It's like a superfood, right? It gives you protein and all the vitamins, and it tastes good. I like it. Yep. Hey, Polar Bear, good to see you. Welcome on in. Happy Saturday. Good to have you here. We're building ourselves a transformer. So we need a labels. Let's see, how are we gonna do this? We need to do a shift on this. So I need to exclude one token. Label target. Labels target. And then labels input. So I need to do labels. And I need to do a slice. We need to slice this. Here, Python. So if we're gonna have L equals, we'll do like 1, 2, 3, 4, right? We need to L. We need to do that. Mine was bok choy. Oh, really? Bok choy? Oh, nice. Bok choy is pretty good. Nice leafy, like a leafy. I know what bok choy is. It's like a small leaf. A transformer? Yeah, you got it, Polar Bear. Which one, Optimus Prime or the voltage enhancer? Oh, right. I forgot there was more than one transformer definition. There sure is. This one's from the transformers right here. Tension's all you need. This is the, if you heard of ChatGPT, you probably have ChatGPT. This is the foundational algorithm to make yourself a chatbot, you guys. Hey, Rival Sebastian, welcome on in. Good to see you. Happy Saturday. Optimus Prime, exactly. All right, best transformer. We have to ask you guys here. Let's do this. Best transformer. Best transformer. We're gonna say, let's see, Optimus Prime, or we'll say electrical transformer, electrical component or something like that, or the GPT generative pre-trained transformer. Generative pre-trained transformer. All right. Which the best one? Which the best one? Bumblebee is fine for now. Hey, Peter Parker! The music really sounds like he's defusing a bomb. A little bit. Also good, I don't really use AI. Kind of don't like it. Oh, Polar Bear. Uh-oh. Uh-oh. You might need to... Hey, Wolf, very cool. Hey, good to see you. Welcome on in. Happy Saturday. Good to have you here. The music's, we're hacking some big organization servers. Exactly. Hey, Bogateer, it's good to see you. Welcome on in. Good to have you here. No, like I don't like using AI while programming. Oh, I failed. Got it. Yes, exactly. So as you can see, we are also not using AI while programming as much as possible. So let me see. I need to grab the entire length. So we do -1 here. So that'll give us. So we need to do input labels will be :-1, like that. And then target labels, I believe, will be 1:, like that. Okay, let's try this. 1:. Yeah, there we go. So that'll be the answer. I think that's correct. All right, and then our input will be here. And then our loss target, where we do labels, here we go, loss _ target. There we go, perfect. I think. Yes. All right. You think we did it? You guys think we did it? Did we make it work? Let's see. Do you know X recommendation algorithm was written in Rust? Are you serious? What? No way! That's great. Hello World Python. Hey, Beast Huntery, good to see ya. Welcome on in. Good to have you back. We're building ourselves a transformer here. Let me go check out your channel. Sounds good. Appreciate it. Okay, we've been doing some transformers. It's open source. Oh, nice. Hello from Turkey. Good to have you. Hello over here from Seattle, Washington, United States. Good to see you. You had RSS for your blog? You did? You added RSS? Nice. Some XML. You've been working with XML over there, Loons? Did you like working with XML? Tell me your experience. Arduino code. Oh, it looks like Arduino code, right? It kind of does a little bit. We're doing PyTorch today. Python for AI. We're building a transformer. AI transformer. Have you heard of generative pre-trained transformer? Chat GPT. Ah, you heard about that? It's not that hard to add one. It's XML, JSON mixed with HTML. I know. A little bit crazy. Nice. Using AI for programming is literally a mean robot building another robot, right? Rival Sebastian, if we were using AI to write AI, it was having AI write it. I know, right? I know. There's a little bit of interesting. You live in Samsun, Turkey. Oh, nice. Very nice. Hope it's good over there. Actually, let's go take a look. So you say Samsun, Turkey. Let's go take a look. This looks like a beautiful city. You've got a bay. Wow, look at that. This almost looks like paradise. Wow, that's beautiful. Very nice. Like a large language model? Exactly, one big floppy. You know it. Exactly. That's what we're doing. You found someone who built a whole large language model trained on cookbooks. That works. Guess what? There goes my idea. Oh no, that's right. You were talking about that. Like you wanted to train an AI specifically on cookbooks. You wanted to do that. I remember you said so. Still tempered to make my own. You're still tempted. Beautiful city. Yeah, this is great. Looks like paradise there. Uh-huh. It looks like what you'd see in the movies. Are there different versions of slicing? Yes, there are. Well, technically, it's one version. It's just different syntax, right? So Sergio, yes, it's just different syntax in different languages, different ways to extract data, and slicing usually happens through a notation that looks like this, where you take bracket from an array and you manipulate it. And PyTorch slicing is really neat. Watch this. So we've got a positional encoding file here, and you can see some very interesting slicing here, right here in the middle of the screen. This part, right here. That part. That is really neat. I like this. You just casually writing Python code to shut down your PC in 10 seconds after showing an alert? Wait, what? Beast Huntery, what are you doing? You're not sponsored, but please don't do your own auth unless you really need it. Yeah, it's a pain. Use something like Clerk or WorkOS. Yeah, cryptography, signatures, validation, identity, authorization, right? Authentication. That's the tricky one, you guys. You taught Rust and you're building AI? Yes, Polar Bear, exactly. Now I'm hopping on to get some help with some college. Nice. Well, if you got any questions, let me know, because I took AI and, basic Python, not enough to do anything useful. Hey, don't worry. It takes a while. It takes a little while, and then you can start considering to build some useful things. Do you use UV or Conda for Python inf? I just use standard Python VM. It's standard, the basic built-in virtual environment. Studying AI as a subject and also learning Python. Nice, one big floppy. That's great to hear. Python's great. It's an industry-leading language that you can use basically everywhere. Oh yeah, when the droid slice in Star Wars, it either opens a locked door or hacks another robot system. I forgot about that. Though, I don't know if I remembered it in the first place, actually. Hey, Quick Fix, good to see you. Welcome on in. Use the Force with UV corn. Yeah, I use UV corn. I do. Web server. Yeah, I'm a newbie to Python, though I have taken AI courses with Python. All right, very nice. That's what we're doing here. Isn't VN built in? Yes. Yes, it is. I use the built-in. Node.js Python is pretty easy, just needs some time and projects. This is a good way to do it. It's a good way. Okay, where are we here? All right, I think we've got everything in the right spot. Let me try this Python transformer. All right, so we got a problem. The batch number of source and target must be equal. The source and target. Okay, so the input needs to be the same. If that's the case, how do we... Let me think about that. Oh wait, this might not be what I thought. All right, so print labels. Here we go. I need to do some debugging here. Target, input, break. There we go. I don't know if I'm going to be able to understand that. Oh, got it. Okay. Let me think about that for a second. Do we need the padding? We do, because they need to be the same shape. The only problem is it's going to see the full picture. So it's not going to be able to train properly. So we have to do something different. Raspberry Pi, Arduino, I'm trying to learn those things. Hey, those are great. So microprocessors, really powerful. Video code it all. Hey, quick fix. Have the AI code everything for you automatically. Would you say it's useful to use a Docker for AI assistant project? Yeah, I would recommend Docker if you have containers. Useful, very useful, because you can reuse the code more easily. All right, it's more portable, and you don't need to worry about dependency problems. It's all built right there into the container. I'd like AI to be able to run the code, but not destroy my computer in any case. Oh yeah, Docker is a good way to help prevent and isolate that, because it creates a whole dedicated virtual container that it can't really escape from. All right, so I see what my problem. I see the problem. I'm currently doing my AI course. It's just basics, really, nothing special. It's the basics are the fun part, really. I think that's really where the fun part is. That's what I mean, retro. Oh, okay, got it. Okay. Good idea. How does the device even understand the subtitles and write them at the bottom? Oh, yeah, right here are subtitles. Yep. It's an open source project that I built many years ago. 8 years. 8 years ago, I started this project, and I didn't use it until just this year. So 8 years, I had it, and then I used it later. Yep. So it allows you to add subtitles to YouTube, Twitch, or any other streaming platform. You could add them to Zoom, Microsoft Teams, Google Meeting, whatever you want. And it gives you overlaid subtitles. You could even do one word subtitle like what you see right now to get one word at a time. And it's on our Discord if you want. It's free forever. Where did the idea come from? The subtitles? It came from watching people on YouTube and Twitch and not being able to hear what they say sometimes. And so I always like to have subtitles. And what you see is in shorts, because this is a new, I always had more than one word on the screen at a time, but I feel like one word on the screen at a time is easier to follow along in some cases. The picture, I know, right? Korean drama. It could have been. It could have been. It's a good source. It's a good source. All right. So I see my problem here. Basically, do we have enough elements? Is this correct? The problem that I have, though, is that it's padded. And so the batch needs to be the same size. So can we do that? Shape? Shape. Let's do shape here. Okay, let's do just the shapes. Oh, wait. Oh, it's not a... Of course, okay. How do we get the dimensions of... I can take a look at the source code. Yeah, it's free. Exactly, it's for free. Open source. Show them the picture I found of you in your DMs. Oh, from many years ago. Okay. All right, Loons, I'll find it. Let me see. Here we go. All right, here we go. Here's an old picture from many years ago. In my 20s. That was 20 years ago now. That was 20 years ago now, you guys. Loons, I have no idea how you found that photo. Like, where did you find it? Since I know a little English, I need an app that will display comments directly in Turkish. Oh, that would be nice, right? That would be amazing to see it in Turkish immediately. Immediately. You didn't age a day. I've been eating. You gotta eat healthy. Eating healthy is the way to go. It's the way to do it. Yeah, Loons, I don't know where you found this photo. That's very impressive that you found that so long ago. So many years ago. Early days. This is like right when I started PubNub. Right when I started PubNub. Like my company here. Right when I started. Get a profile picture on Wayback Machine of the PubNub SDK. Oh, that's where you got it. Okay. That's where you'd have it. Exactly. Yep. Because I updated it. Eating healthy and strict sunscreen regimen. Exactly, J Loons. J Looney. Exactly. You got it. You got it. Whoop. 1 second. Okay. I want to go back to this. Here we go. Clicking. Okay, good. All right. Wait, it has a translator too? Yes. Yes, it does. You can do languages. You support multiple languages. You can set the language. There's English, Spanish, Mandarin, German, Japanese. And there's even more. If you click on this language code page, you can do about 100 plus languages. So if this is ChatGPT is a transformer, then natural language processing is used. Are you also making complex NLP algorithms? Well, you know what? We could make an NLP because we've got an embedding, right here. What we can do is we can detach the transformer and grab just the embedding output, and that will allow us to create NLP. We could. We just detach right here, and we got our own NLP right there. You tried learning neural networks. You didn't make artificial neurons. I lost mine. Oh no, you failed miserably, Matchstick. Oh no. Hey, it's okay. That part is important. The failure is part of the learning process. You figured out what didn't work. Now you just got to try over and over until you eventually get it. Nice. Yes. It's the way to do it. Exactly. Okay. Let's continue on. So we've got a problem with this piece here. This part is a problem. So can we do len? Here we go. Okay, let's see. Let's see what we got here, you guys. Okay. Okay. That's why. Well, they're both 9. They're both 9. So, oh, I see what I did wrong. I see what I did wrong now. Okay, it's not as hard as I thought it was. Okay. Do I need to learn how to write the algorithms from scratch to actually learn how to build them out? You do? Hey, Sam D. Dev, good question. Do I need to know the algorithms underlying all the machine learning frameworks? The answer is you don't. You don't need to know them. You can easily build any AI model just using a framework like TensorFlow and Keras, or PyTorch, or JAX. There's also Burn and Rust, and there's TinyGrad. There's a whole bunch of different options available. You can also use scikit-learn. These will give you all the necessary functions to be able to build the AI that you're looking for, and you don't need to understand the underlying ML. However, I really like knowing what it is. I like it. You don't need, yeah, exactly. You don't need just use scikit-learn. Exactly, Matchstick, exactly. So I need to back propagate. Yes, the back propagation equals, so back is it propagation equals learning. This is where the model learns, right? So this will be generating gradients, which is just the delta of inaccuracy when you go through the back pass. So basically you take the loss and then you backtrack based on the loss. And you create hard gradients. These gradients can then be applied to your original model weights. So that way they get updated. And you usually apply a learning rate to it, because if you put the learning rate to 1, which is 100%, the model will perfectly learn only that one thing. And so the idea is you want to train the model on a whole bunch of things so it can generalize. It's a really beginner friendly. It is, yeah, scikit-learn's a good one. sklearn. If you don't want to write code, use something called Orange. It gives you a GUI. What is Orange? I've never seen it. Oh yeah, would learning by connecting to games be a good way? I think so. That's actually a good way to learn. Yeah, I would use it as a good learning. He wrote layers. No way. Wait, layers. What? You know? Yes, you know? All right, we got the JM. Get those layers going. See, the problem is, so I don't know what a gradient or a derivative is, so I don't understand anything. Don't worry, it's okay. They're just annoying math terms. They are annoying math terms. It's this problem that I have with the math community. Hey, I'm talking to you, math community. You bring all these fancy words that prevent and dissuade others from joining in to learn your amazing capabilities. It's you math echelon. You don't need to have those fancy words. A gradient is just a bunch of numbers. It's okay. Stochastic just means random. You don't need to come up with these extra words that confuse the situation. You don't have to. Stephen Hawkins. Mr. Hey, how's it going? Good to see you. Blinvincible. It's Mr. Blinvincible, you guys. The best transformer is a super heterodyne. Wait, what is that? A super heterodyne. It converts between different frequencies for processing radio waves. Oh, Jay Looney. I see what you said there. Okay. Yep. You're talking about something in the physical world. Exactly, Matchstick. Training very well on one thing. How is that useful? It's not. It's just something you could do if you wanted to. It just repeats the training data. Yeah, exactly. You could if you wanted to, you could. It won't help you a lot, but it'll work. Trig is ridiculously simple. It's pretty much just intuition. Trigonometry, you guys. You're awesome, dude. Hey, thank you. I appreciate it. That's really nice for you to say. I am very happy. All right, so I see what our problem is here. We did it wrong because we removed the batch from the target. So we need to do this differently. I need to update, because this is the raw data. So I have to go through. Let me just print. Let me see here for a second. Did we normalize it? So the problem is I'm grabbing the targets and labels before. So I need to pad it. Would that work? I think it will. Okay. I just need to think about this a little bit differently. How would you know when to use k-fold or train test split and how to do it? So I know what I've not used. I might have used k-fold. I just didn't know what it was called. And I've used train test split. You should always use train test split because you can train your data. You need to be able. The idea is, all right, how do we do this? So we got some things, yeah. All right. So you've got your entire training data set, right? All training data, right? You get everything. All of your training data, right here. It's a bunch of data samples, right? Probably a bunch of words, let's say. It's a whole bunch of words. What you're gonna wanna do is you split that data so that way you make it into segments. So you're gonna split it into like 70-30 usually, right? So this is 70% of the data, which you'll use to train it, 30% to test it. The testing is important because you wanna make sure that the model that you created can generalize enough to accurately predict the 30% that you set aside. If you don't do that, you won't have anything to test it on, and you can train 100% of the data on the model, but you won't know if it really worked. K-fold is just cross valve score, right? In scikit-learn? Matchstick. Let's see, K-fold. K-fold. Yeah, exactly. I think that's what you're talking about. Let's see what K-fold is. Orange is kind of like Scratch. Oh, got it. Okay, so it's Scratch, like you drag and drop. It implements models, processing functions. Okay, so yeah, okay, so it's like a giant drag and drop. So you can put together a bunch of parts of AI algorithms, piece them together with pipes and things. A resampling method used in machine learning to evaluate models' performance, preventing overfitting. All right. Partitions the data set into k equal sizes, subsets called folds. The model trained on k folds and tests on the remaining fold. Repeating this process k times, so every fold acts as a test. Oh. Acts as the test set. Exactly. By average scores. Okay. Neat. Every data point is used for both training and testing. Okay. I got it. All right. I understand it now. So with K-fold, it's like you split your data into training and testing all at once. So this is training test split. You can do the same thing. With K-fold is different though, right? How do we do this? K-fold. All right. So K-fold will be like you have different segments. So you have a bunch of different slices of your data, right? And you do testing and training on each of these incrementally. Is that right? Thank you so much. Hey, we're learning together. You can do input output conversion, and it's a very useful component. You can only work on 900 megahertz. The live signal actually is 80 to 90 megahertz, or any variation of that sort of thing. Jay Looney, okay. Transformers, the more we know. You can make pipes. Really, in orange, yes, in orange, you can make pipes. Good night, bro. All right, sounds good. You're sleeping now. And Kit, all right. Thank you so much for joining in. Good to have you. Have the rest of your Saturday. I hope it's good, although it might be Sunday for you now. It's a step that the benchmarks are becoming useless. Oh, wait, are they the correct? If the correct result is a bench of the finish of the input testing of the training data, it would be 100% to train, and you would use the same training data for testing. Exactly. Yeah, you were taught K-fold in your AI class. This is neat. I haven't ever used this approach, though I can see why it's actually really valuable. I can see it's a good one. It's a good one. Thank you. We're learning together. One big floppy. Thank you. What do you do when you have some software to work on and you just don't feel like working on it and you have a deadline soon? Oh, Sandy Dev, yeah. Activate deadline mode, right? You activate deadline mode. Activate deadline mode. All right, here I'm going to show you. Are you ready? I'll show you the secret. The secret is you just lie to yourself. You wake up and you say, everything's fine, but you're really just lying to yourself. You're just, it's okay. No, just lie to yourself. All right, here. Activate deadline mode. All right, you ready?
The deadline approaches without mercy, and I stare at an empty screen.
We procrastinated for too long, and now we suffer.
Yes, thank you for the reminder, Brain. Now, can you do that thing that makes us do all the doings in the last minute?
Well, in that case, I must activate
Deadline mode.
Yeah, deadline. I'm typing again. Oh. It's like magic. Ah. Right. Ah.
Deadline mode.
Deadline mode saves us.
Once more. Yep, there you go. Deadline mode, you guys. Do all the doing. Yeah, exactly. Sam D. Dev, you've got it. Now you got it. You know what to do. Dash Shafari, how it's going over there? Well, check out JEPA by the researcher who came up with GPT, generated pre-trained transformer. Yeah, hey, that's what we're gonna do. That's the plan. We got it right here. JEPA. We're going to be doing some JEPA. Deadline mode is so useful. It is, right? Activate deadline mode, you guys. That's the answer. It's the way to do it. All right. I know what's wrong with my code here. I just need to think about how to fix it because I'm adjusting the batches and I don't want to adjust the batches. I want to adjust the data inside the batches. So I need to do, my batch needs to return something different. So I've got my training data. Let's see here. Training data. Where is it at? Okay, generate math. And it also pads it here, and that's a problem. It's a problem, and I think I don't need to do that. So I'm going to make some adjustments here. Match 6, Steven, that was cross val score does. I don't know. Scarlet Fire Loons, yes, Scarlet Fire. We're doing that right now. So sometimes deadline mode is too powerful. I kicked it once and accidentally wrote 15 pages for a one-page short. Oh yeah, you wrote too much. Jay Looney, you went over deadline mode. You use it all the time, Loons? Nice. We're gonna have a GPT Prime. Oh yeah, we're building GPT Prime, you guys. Steven, that was cross-validation score. Yes, so we are using, we're using cross entropy. Oh, cross validation. Oh, right. So that's another approach. So you've got k-fold, you've got training test split, and then you've got cross validation. Different approaches. Got it. Enlighten me on what we're doing here. Briefly, just came in and had a brain scrambled. Hey, we're building a transformer. Of course, you've heard of generative pre-trained transformers. Chat GPT, that's what we're doing today. We're building this right now, and we're currently getting some stuff updated with our batching. We're doing some batching improvements. Then we're going to add in positional encoding, and then we can train our own AI to do whatever we want. Gotta go, Loons. All right, sounds good. Sounds good. Let's see, where are we at here? Okay. So I just need to fix my generation data, and then I need to fix a couple other things, and then we can add the positional encoding. We're building AI, you guys. Steven, so far in working on classification regression models, but how would you suggest I approach large language models? Do it like I'm doing it. So I started off with embedding. I wrote my own embedding model. Dina, who's Derek, recommended that I write my own. So I recommend testing out the embedding. We did this on PyTorch, the website. So there's an embedding here, word embeddings. It's a tutorial on PyTorch's website. We went through this live on stream and we wrote our own. Then you can go into Transformer, which is what we're doing here. We're just using the built-in Transformer model right here, which means that it makes it easier, it's quicker. After we're successful, we're gonna go in even further and we're gonna write our own transformer layer. Even make GTA 7 with that AI? Oh, I know, right? Could you? No, it won't. It won't make it. It won't make it. I know you're asking, Beast Huntery. You're asking. We'll try, but it won't do it. I promise. It's not gonna be good enough for that, though we can still try, right? It's a guaranteed failure if you don't try. So I say, let's give it a shot. All right, Steven, I'm a dip, 12 a.m. I'm going to sleep. All right, sounds good, Matchstick. Good to have you here. Thank you for all the suggestions and ideas. You made our day better. If you learn how to build Transformer, do you also learn how to do fine tuning? Ah, that's also a separate item. Yeah, we did LoRa fine tuning last week. We did LoRa fine tuning. We did it. We succeeded and we got it to learn new things. We did fine tuning and it really worked. It's real. It's not a fake. It's not fake news. It's real. You can really do fine tuning and it really works. Yeah, we did LoRa. So we did low rank adaptation, fine tuning. We did. It's on our, you can see it. It's in our YouTube. What makes it different? LoRa, it does it instead of just appending a layer on the output, you can append, it sits beside it, right? So it's a side by side rather than a tack on, adding a new layer at the bottom. So, which it also does, by the way. It also kind of does that. Right? You know what I mean? From prompting, oh, it'll give the model more knowledge at a zero cost of adding new weights. So that's one of the bonuses. It won't, so LoRa fine tuning, archive paper, low rank adaptation. Look at the PDF here. Here we go. So the rank part is it creates a lower dimensionality matrix pair. So it creates two linear layers, linear layer 1, linear layer 2. The rank is going to be a lower dimension, right? That's lower dimension. So that much makes it a low rank. And it's side by side with your original model. You pass X through on either side. B is going to be 0 initially, and then you just add the numbers together. It's just adding the numbers. Really, AI? Really? You just add the numbers? Yes, you're adding numbers. Wait a second! That doesn't make any sense! Yes, it really does. It really does. I promise. You're just adding numbers. Yeah, video games. Hey, good to see ya! Welcome on back. You joined in yesterday. Thank you for coming back today. Yay, video games. Did you do the magazine, right? You're talking about a magazine? Did you do the magazine? Have you made progress? Won't it be very hard to run a huge model on your device? Yes. Yeah. Sam D, yeah. Yes. It will be. You got it. So you need to be able to have a device that can work side by side. The great part is once you're done training your LoRa layers, you just merge them in directly on top of your existing weights, and then you've generated a new model that learns new things, you guys. It's great. I saw a video on how GPUs work and how they are made. Oh yeah, lithography. About 60 billion transistors on a chip. Light waves. They're shooting light waves, and I think they did some weird refraction now to get the nanometers so small. Got a bunch of ideas for it? Yes, I have got progress. Nice! That's good to hear! Sorry to ask an irrelevant favor. Please do you monkey typing speed test. I really want to see you do that. All right. Let's see. Monkey type speed test. All right. I've done this before. I like this one. It's a good one. All right, are you guys ready? I'm very average, so don't get too excited. And I really want to go back to our programming. We'll take a little break here for a second from Python AI, right? First, for that, another child program, old, however, I gotta type it right. From the take of C hold this. Wait. School or whatever. From do also want date. People would. Thing still. Oh my God. Ask. Good. All right. Should for. All right. There we go. All right. We did it. There you go. There's monkey type. I love your energy. Thank you, Sam D. Appreciate it. You ever wonder why I have the name Yeah Video Games? I thought it sounds like a business name. It seems like a business name. Really nice. It's pretty good. Yeah. All right. Good to hear. Thank you. Does Pi Audio even work? Yeah, it does. Because last time I tried to install it using pip, it was failing. Oh, well, you're probably missing some dependencies. It might have had a problem on your architecture. You probably try it again. You need to install it. You might want to install it with Conda or UV or instead of pip, right? Sometimes you got to use a different package manager. So at Beast, yes, try diff package manager like UV or Conda. I If you go to YouTube, you can answer. All right, let's find out. This it right here? Yeah, video games? This channel will be informational on the Wayback Machine. No name and Minecraft ARGs are many more. I don't fully understand it, but okay. Also, I see that it's a new account. The love of energy you have, what I want in my life. Oh, thank you. Yeah, just gotta eat healthy. Eat healthy and you'll have all the energy in the world. It works really well. It does. When I say eat healthy, I mean eat vegetables and fruit, beans and grains, berries and seeds. That's it. That's it. And eat that for every meal for the rest of your life and you'll love it and you'll be so happy about it. Okay, thanks, Beast Hunter. Yep, you're welcome. Okay. So, where are we here? I need to adjust how I'm generating my data. We're going to remove the padding. All right, just going to remove the padding. Just to do that for now. Might as well. Let's get rid of that padding. Okay. Then, I want to do extra step here. Oh, no. Actually, it might be okay. It might be okay. Maybe. That might be a problem. We're going to try it. We'll try it. Just in case I'll... There we go. Okay, there we go. Perfect. All right. So I'm going to keep that around just in case I need it. And then I want to generate... All right, so now I don't have padding anymore, which is fine. And then I need to update how I'm generating my batch. I need to do target labels. Labels and then target. So we call this in label. This is confusing. I have to give them real names. And there needs to be 3 dictionaries here, not just 2. Because when we're grabbing the sample, I need to apply the delta here. So target in, target in, target out. Target. How about this? Labels, target in. All right. What is this called here? Right here. This is called this second input. Outputs? It's not outputs. It's almost outputs. It's like outputs shifted right is what it is. So it's output shifted right. Was a person who was a Jehovah's Witness. Oh, wait, really? He would type nonsense posts on Reddit. It was because he had several sicknesses and felt a lot of pain, but then on Tubitini. Oh, okay. Well, all right. That's concerning. Gotta go soon. All right, Sergio. It's the weekend. I understand. We're just gonna be building some AI over here. It's so good to have you here, Sergio. Hey, Song 1865, welcome on in. Thank you for saying hi. Good to have you here. Outputs shifted. So we can just say outputs shifted and then outputs. Outputs. There we go. All right, then we're going to do outputs shifted and then outputs standard. And we need to adjust this. Needs to go one direction. How do we do this? Here. Okay. Right. Target and input. Labels, target, labels, input. Shifted and outputs here. We need to append this on the target. The shifted, yes. Input. No, we have to do this one on the input, right? We got to take away the rest one. So this is the input. There we go. And then this is on the output. Here we go. All right. That should do it. So I need to return features, shifted, and then the output. Why don't we just call it shifted to keep things a little bit cleaner? Okay, there we go. All right, so shifted and outputs. Perfect. Which IDE do you use? Thanks for streaming today, Sergio. Thank you. Yeah, absolutely. Good to have you here. For Python, this is Vim right here. This is Vim text editor. This is my favorite text editor in the world. Why do you think the transformer works so well? Tech Maniac, yeah. I see what you said there. The transformer, why does it work so well? Because it's got built-in correlation coefficient, which they really just said it looked fancy. They just did. So when you do feature selection in your AI models, when you're training, you do feature selection, you do something called correlation coefficient matrix, which is going to create a relationship about how things compare to each other. And you essentially can use it to reduce the number of features that don't matter or make any impact on your model, or actually detract and take away noise. What they've done here is they've added an embedded correlation coefficient matrix that creates self-attention. I think this is the most important part right here. The transformer itself has the combination of a convolutional neural network, the filters, the combination of correlation coefficient, which is the self-selecting features, and they compare three-way. So it's like a doubling up of the correlation without losing the values of the original words. So it adds more detail. And to make the large language model larger, they added positional encodings, so that way you can see where in the token, which token, how it relates to other tokens. It's just a bunch of math all stuck together, is what it is. It's a whole bunch of math! Oh, yeah, video games? Got it, okay. YouTube doesn't know? Okay. It's all good, it's all good. This is extremely cool. Jay Lund, I know, it's really neat. It's my favorite, it's my favorite. It's crazy this is somehow creates intelligence. Yeah, it creates a really good word predictor, right? It creates a really good word predictor. Because the output, the final output here, let's see here, probabilities, right? It's just one, it says the probability of which is the next word. This entire thing is only going to predict the one next word. And that's how AI works. So they're not really being super novel here. They just have a whole bunch of classes, a whole bunch of word possibilities, right? A bunch of word possibilities. So they just scaled it up. It feels like there should be a lot of novelty in here, and they just made this little teeny change, and it created something that we all see as intelligence, right? Artificial. All right, let's get back to our code, you guys. You worked on Lisa Dirick and Jen Rose at Wesleyan University a long time ago. They were great feature selection, but just by looking at the soup of numbers, I never imagined visualizer like this. Oh, okay, yeah. It's really neat. It's really neat. Jay Looney. It's pretty cool. I like it. Scaling was the breakthrough. Yeah, that's fair to say, Tech Maniac. I agree. You're right. It's fair to say. It was the scaling. So they were able to take smaller models, tweak them in a way that allows a lot more data to be consumed and processed. That's the innovation. The breakthrough. Vim is just keyboard only. That's right, keyboard only. You don't need a mouse for this, right? This is my mouse, by the way. Magic trackpad. Like retro and manual stuff, Notepad++, yeah, I remember that. Notepad++, good days on Windows. Okay. So now we did the proper here. Now, after I do this shifting, I might add padding, though I don't know if I think I might need to. I'm pretty sure I do. Though if I did, then it would be a problem. All right, let's see if this will work. Okay. Now we need to get our training data on our inputs. Features shifted. So what do we call this? We call this shifted. Shifted in outputs. Okay. Here we go. Okay. Features shifted outputs. All right. We don't need this anymore. Don't need that. Okay. Do you also try Helix as an editor? Oh, yeah. I've tried Helix. I've tried LazyVim and a couple others. There's also HG, right? Is Helix HG? The HG for Helix, I think, right? Wait, did I hear my name? Retro? Yeah, you did. You heard? Yep, you did. Retro, exactly. We're original OG. OG, old school. You really speak with a lot of clarity. Kudos. Thank you, Tech Maniac. That's great to hear. Good feedback. I appreciate it. Thank you very much. All right, let's see if we got everything correct now. So I'm going to do shifted and outputs here. Okay, now we got it right. We have features. Okay, here we go. So it should be 10. It should be 10. All 10s. Perfect. Perfect. Yeah, there we go. All right, that part's done. Now that we removed the padding, is that going to be a problem? I don't know. Vin bindings are hard-coded into your muscle memory. Yeah, you try to play with Helix too. If you, yeah, exactly, because it's a whole nother keystroke. It's a new pattern that you have to memorize. You got to memorize it. Do you, by the way, do CUDA or GPU programming? Tech Maniac? We will. That's part of the plan. We got so much time left in the world. All right, so the plan is we're going to do some CUDA kernel programming, right? We're going to do some Haskell. I'm going to do some Haskell. I want to learn JAX, so we'll also do some JAX streaming. We'll do some more algorithms, some more AI algorithm streams. We've got a whole bunch of things to do. We got a lot. There's so many fun things to do. All right, let's see if this works. No breaky, no breaky, no breaky. Oh, right. Let's see how shifted is what we need here. There we go. See if that works. I knew it. Expected sequence length of 1 got 2. Yeah. All right. I understand. If we do batch size of 1, will that fix it or not? The shape of the 2D attention mask is, but should be 2 by 2. Darn. Okay. All right. You know what? I'm just going to bring this back real quick. See if that still works. Hold on. Batch size 10. All right. See if this works. All right. We broke it. You guys. Yeah, need to learn those. Yo, all right. Almost the same kind of thing in your mind. Nice, Tech Maniac. Haskell's on my list for a long time. That's a good one. Hey, Matchstick, you're back because you couldn't sleep. All right. Well, let's see if we can help you fall asleep. What I do is I always go on, like, I watch some TV or something before I go to sleep, and then right before I fall asleep, I click the turn off button because it helps. What keeps you awake is when your mind races, like when you're thinking about things. That's what keeps you awake. No, we need watch coding. Yeah, exactly. Watch coding. Then it's a good way because it keeps you focused externally. Because if you're like running around in your head up here, it's easy to not fall asleep. Coding works really well though. The shape of the 2D attention torch 1010 should be 9:9. Why? Oh, wait. Really? Is that true? Hey, Impulsar, good to see you. Welcome on back. It's been a while. Only a little bit, right? Hello, good to see you. Happy Saturday. All I can think about right now is Gaussian support vector machines, SVMs. Hey, Matchsticks. I like this. This is one of my favorites. Support vector machines. Really interested in hardware, how a computer works, and how from hardware wires and stuff are to software. Oh, yeah. And I love retro and old computers and machines. Basically, I love everything about computers. Beast Huntery. That's great to hear. They're like magical. If you were to see anything other than like, sleight of hand in Magic, today, the thing that kind of feels like wizardry is computers. It seems like it, right? It's like the closest thing that we have to magic. I think so. All right, so what I'm going to do is I'm just going to try returning original. Do, how are we gonna do this? I've got an idea. Okay. We're just going to return shifted like this. And then we're gonna use shifted for both. So we'll just say shifted. Let's see if that fixes it. All right, shifted, and then that should fix it, right? All right, so no errors that time, right? Because we didn't change the output size. So what I really need to do is see what's going on in here. Insane seems almost alien tech. It does, right? Systems are insane. ASML? Wait, what is ASML? Google ASML. That is a holding company. I'm pretty sure that's not what you meant. Absolutely agree. Nice. Sometimes you're wondering if you're going insane. It could, yeah, right? I know. We're walking a fine line right now between consciousness and insanity. We're right on the edge, you guys. I think the best magic is still in our mind. Human, the brain, Torva. You mean our imagination or just our brain in general because of how amazing human brains are? Is that what you're saying? Because we're still better than computers, even as amazing they are. Have a good day, guys. See you later, Sergio. Thank you for seeing us today. Have a good rest of your Saturday. There are machines that do the CPU on the silicon wafers. Uh-huh. Yeah, exactly. Thank you for the likes, you guys. All right. Okay. All right. Let's see. Let's see if we get a new quick poll here. Start a poll. All right. Favorite AI framework? sklearn, JAX, Google, or we do TensorFlow/Keras, or would you say PyTorch? I'm putting my favorite at the bottom. I don't know about you guys. Okay. So why did that do what I wanted? PyTorch number 1. All right, 100%. So why is this not doing the thing? Oh, because it's a string, right? Can we do that? Python. Can we do a string? Ooh, can we do :-1? Yeah, that works too. That works too. Why is that not working here? Are we doing it incorrectly? No, we're doing this properly. I need to print this out. Okay. Let's print out shifted lang. And we should print out features as well. Okay. Where are we at here? Where are we at? Oh, the padding. All right, we brought the padding back. Let me turn off the padding really quick. All right. This is fine. It's fine. It's fine. Fine. Okay. Yeah. Let's see here. There's an empty one. Okay. That's why. All right. Yeah. Yeah, it makes sense. Okay. Yep. Okay. I need to think about that for a second. What if we change where the equal sign is? In fact, we are computers like DNA, and the genes are our source code. RNA, like compilers or interpreters, and the proteins created by it are like machine code or actual physical execution of code. We've rebuilt nature in computers. Beast Huntery, that's crazy. Good night, Steven. Happy coding. Thank you, Tech Maniac. Good to have you here. Enjoy the rest of your weekend. Whoa, Beast Huntery, that is pretty impressive. Basically, we've created a mirror of nature in computers because it's very similar. That's what you just described. Okay, where is it? How do we want to do this? All right, where am I at here really quick? This is the one thing that I have to at least get done today is fixing the batching, which we did. I just need to make sure that the model is able to train on seeing this with the shifted data. We've got to shift the data. Shifted, output, and then features. All right. How about we do this really quick? I want to see what the original is. So I do see it. So that is the output, yes. Off by 1. Yep. And this is the original. So let's take a look at... Let's just do this really quick so I understand it a little bit easier. And then we're going to say shifted, output, and then original. Okay. This looks good to me. Okay. And then I want one epoch, so that way I can see a little bit easier. Here we go. Okay. So here's the original. Oh wait, I also should update this here really quick. This needs to go back to the way it was before. Okay. Original string. Then we've got... Oh, wait. Oh, wait. This is not tokenized. I see what I'm doing wrong. Okay. You got accepted to uni today. I'm so great mood. Hey, Pulsar, congratulations. Whoa, that's a big deal. Is it the place that you wanted to go? Did you got in? Well, it sounds like it. It sounds like you achieved your objective. Good job. Good job at achieving your objective. You're gonna do great. So I mean, technically those are already tokens. So if I can split them here, it should be fine. I feel like. It seems like it should be something that we can do. And then we need to add padding. There's just so much to this. Do we really need to pad it though? Is that a problem? Is it though? Because it's not though otherwise. Yeah, it is also. Thank you. Hey, very nice to hear it. That's fantastic. All right. That's so great. You found your adventure. All right, so we've got right here. I know where do I want to? I understand the deal that I need to deal with. I'm just not sure about it. Yep. So we've got 84, and you can see 8 or 4. Right. So this is the output. This is the shifted. Because when we put the target input, does it need to be the same shape? If we restore, what if we did 10 and like 4? Okay, try this. Yeah, that looks good. Okay. Oh. All right. Well, they're all uniform now. Let's just go with that. And then we'll call it done. It's not perfect. I would say it's fine. It's fine though. It's perfectly fine. It's not exactly what I wanted, but it's good enough. Okay. So we've got our shifted. Need to restore this. And then we've got our features, shifted, and output. Features, shifted, outputs. Double check still looks good. Okay. Yep, looking good. And then we need to test the output again. And no errors. Oh no, we got an error. Why? I thought I fixed it. The shape of the 2D attention max 10 should be 3x3. Oh. Because I only made it 3x3. Right. Okay. So mask. We need to make it dynamic. Embedding size 1. There we go. Hey, is that the answer? Did we fix it, please? Yeah, there we go. We fixed it. All right. I knew we'd do that. All right. Little easy thing right there. See, this is like, now we're really cooking, right? Now we're really cooking. This is great. Okay. I'm just like so amazed that that phrase, you know, let them cook, you know, let them cook. That is it's so old, and it's just spanned the ages. It's been around for decades. Okay. Here we go. Now I'm going to try and see if we can get to the loss. Let's see if we can make it. Let's see if we can make it, you guys. Oh. We can fix that. We can figure that. So targets, we're going to tokenize. And this is going to be the outputs. No. I want to change the name. This is not great. This is shifted and then target. Oh, I think targets is better. Targets. No, if I how about we just say target? Target. No. Target. And then we say target here. All right. That should do it. Let them cook. Exactly, rival. Exactly. Okay. Hey, there we go. That's what I want right there. All right. We're doing good. Get rid of our debug statements. We don't need those anymore. Let's get rid of those. Okay. Bring back up our epochs. Run. Yeah, that looks good. Took a little while to learn, though. Took a little extra learning. Just a smidgen more learning. It didn't perform as well, which is annoying. I thought after all that. What if we do 10? Okay. That's fine. Best platform to learn web development. The best platform? What do you mean? So are you talking about operating system? They're all the same. Windows, Linux, or Mac, doesn't really matter. You can learn on any platform. The best online education? You probably get something for free. I would say at W3 Schools. This is a good one. You can learn HTML right here for web development. Right? There's some good ones there. It's got a lot of ads, but it's free. W3 Schools Alternatives. What do we got? Let's see if I recognize any of these. Code Academy, Khan Academy, some Udacity, right? Does it have boot.dev? Code Easy, Code Wars. All these are great. It's just whatever you want to put your effort into, right? You can do any of them. Start with one. I'd recommend starting with the free ones. Don't pay for anything. Start with the free stuff first, right? Then, if you want, and you really, really want to, then go into the paid stuff. Khan Academy is great, but it's costly. It's expensive, right? Yeah, exactly. We all have nucleotides like ATGC in DNA, which are chemical compounds in different permutations and combinations. Are source code. They are, right? So RNA decodes and it makes proteins for execution of that code. It's the way nature executes logic. It is. It sure is, Beast Huntery. You got it. You got it very much. Yeah, my model's not learning as well as it used to. It's just not learning as well as it... Well, probably the reason why it's not learning as well as it used to is because I'm extracting the data from it. I'm giving it different data. So it's having a harder time learning because it doesn't have the answers immediately. But it's still learning. So epoch. Let's do 100. Do 100 epoch. Is that still... Yeah, all right. It's doing good. Okay, look at that. Hey, it's still working. All right. Satisfaction guaranteed. Let's see now if we can do some... For each batch, we'll print out some answers. So, decode output. Yes, I think we can still do this here. I think so. Any idea on data annotation? I tried their paid works, but it has banned you. Wait, what do you mean? They banned you? For why? Why'd they do that? Any idea on data annotation? Well, data annotations usually, from what I understand with what you're describing, we're talking in the machine learning world, right? AI, where you have data. Annotating the data creates labels for the data. Labels are just the essential answers, right? So if you have a bunch of photographs, you can label that data with text saying, oh, there's a dog in this photo, there's a cat in the photo, there's an airplane in the photo, right? That's data labeling. That's the process of annotation. Training the LLMs. Oh, okay. So training the LLMs is a little different because you have inputs and outputs, right? So typically a question to answer bot. So if you have a question and then you've got an answer, right? So you can do something like this, where you've got input data and output data, right? Input data, output data. And you can train an LLM on this data. So you just need to create the training data so it has input and output targets. And you're good to go. That's where that works, yeah? And so you said you wrote your own? Let's see here. All right. So probably tomorrow what we're going to do is positional encoding, because we didn't quite get to it today. Oh, hey. Why is that not good? Tensor with 17 elements cannot be converted to a scalar. Well, sure. Of course they can't. Oh, because it's a batch. We have to take care of batches in this. Okay. Outputs. All right, I'd like to see at least some printing of the data here. For output in outputs. Let's see, we've got our words. Let's see, answer. Let's see here. Batch equals empty. Words. We just need to say batch.append. Batch.append. And we return the batch. Here we go. Is that gonna do it? Is that gonna do it? Nope, because I got the spell properly. And then words. Where's my words at? Where is that at? You said line 187? 187? Oh. Sequence item 0, expected string instance, found lists. Yeah. How about we just print it? We don't need to join. Let's print. Wait. Hey, there we go. Look at that. It's giving us the answers. Perfect. All right, we did it, you guys. We succeeded. We did it. All right. So now that we've got batching finally done, sort of, I would say like it's 98% there. Don't look at anything else. Yeah. Oh, well, wait. Is this actually working? It is. It is working. Okay. Wow, congrats. I know, Beast Huntery. We did it. We made it work. So, the plan for tomorrow is we're going to use the positional encoding inspiration to add our own positional encodings. I might do dropout. Dropout's really easy. It's not like it's a hard thing to add, right? It's right there. It's an easy. So we might keep it. The thing is, we will need to sort of think about how this works. We will understand this code as the plan for tomorrow. Thank you, Beast Hunter. I appreciate it. We are going to head out, you guys. Had a great day today. Enjoyed hanging out with you. We'll be back tomorrow to build more AI. We're going to add positional encoding tomorrow. So we finished our batching today, which was great. Tomorrow, we'll be doing some more. And the final part, it's the final part, is the positional encoding. And then we finished it. We did it. We finished it. W3 Schools is amazing. It's pretty good, right? Yeah. I like W3 Schools. It's been around for quite a while, and it's free. It's for free. All right, guys, thank you so much for joining in today. We'll be back tomorrow. Have a good rest of your weekend. We'll be talking to you on the next stream. See you guys. Bye, everybody. Bye, Beast Huntery. Good to see you. Good to see everybody. See you, Rival. Rival. See you, Rival Sebastian. See you, J-Bro. Bye, everybody. Have a good rest of your day. Or night. Hey. That too. See you, Torva. Thank you for joining. We'll be back tomorrow, Torva. Bye, everybody.